Good day, guys. Welcome back to Emoji Economics YouTube channel. Um, Hope you're good, right? In today's lesson, we're looking at sword. You may be wondering, sword economics, like what's the problem? I think I've said it before. I've said it before that economics is incredibly mathematical. Economics applies mathematical concepts in communicating its theories, its findings, and what have you. So, what exactly is sword? A sword is an expression that includes a square root, a cube root, or any other kind of root, right? So, when you see something like root 5, root 7, things like that, or 3 root 2, 4 root 8, blah, 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 like that. Okay. So, swords are used to write irrational numbers precisely. Irrational numbers. So the point is, what are rational numbers? So we need to understand rational numbers before we know irrational numbers. So rational numbers are numbers that can be expressed as a fraction of two integers. So if you have any number that you can express exactly as a fraction of two integers, then that is a rational number. For example, 4, right? 4 is a rational number because you could express 4 in the form of 8 divided by 2, 16 divided by 4, right? Um, 32 divided by 8, it's like that. That gives us 4 exactly. How about if you have something like 1.25? Like 1.25, you could just express 1.25 as 125 divided by 100. And so that gives you the exact 1.25 back. So which means 1.25 is a rational number, right? Any number that you can express as a fraction of two integers, that's a rational number. Then what if you now have recurring decimals? Let's say you have something like, I think I have an example here. Um, 0.1717, 0.17, when you have a number like this, 0.171717, like that. So is this a rational number or an irrational number? So can you express this as a ratio of two integers? Yes, we can. And what we just have to do is 2 divided by 9. So if you do 2 divided by 9, you're going to have this, decimal here. So if you have a recurring decimal or you have an exact decimal, something like a decimal that has an end to it, like the 1.25 I said, that's the end to it. Or you have a recurring decimal like this, 0.171717, or 0.333333 like that, or 1.3333 like that. So that is recurring. It's not ending, but it's recurring. Those are still part of rational numbers because you can express them as a ratio of two integers, right? And it's going to give you the same result. Now, what else is a rational number? Root 25 is a rational number because root 25 is just going to give you 5. And you can express 5 as a ratio of two integers. So we can otherwise say that root 25 is the same as 100 over 20. So that makes root 25 a rational number. Is that okay? Now, irrational numbers are now the numbers that you cannot express as a ratio of two integers. So we may even be wondering, what are integers? So integers are basically your whole numbers. So your whole numbers, 1, 2, 3, 4, 5, 0. Like all numbers start from 0, then 1, 2, 3, 4, 5, 6, 7, 8, like on and on like that on the number line, the positive side of the number line. So integers include the whole numbers and their corresponding negative numbers. So for example, 0, 1, minus 1, 2, minus 2, 3, minus 3, it's like that. So integer is encompassing like more than the whole numbers. So we are just saying that as long as you can express a fraction, a number as a fraction of two integers now, so you have a rational number. So for irrational numbers, these are numbers that you cannot express as a fraction of two integers. Now, for example, how do you express root 7? So root 7 is 2.64 5751, then it continues like that. So there are not numbers that you can divide by each other that will exactly give you this. So at best you are going to be having an approximation. So because you cannot express root 7 as an exact ratio or fraction of two integers, root 7 then becomes an irrational number, right? So that's just the point about rational and irrational numbers. So you can say that sword is helping us to depict whatever root 7 means exactly. So root 7, so it gives us all of this. So you can express all of these numbers in the form of root 7. All right, so this sword helps us to do this kind of a thing. Now, how about pi? So is pi a rational number? If you remember, pi 3, we in mathematics, for those that are doing mensuration and all of that, you would say use 3.142. Like if um like an approximation for pi, like use 3.142. So instead of just using pi, exactly. And maybe some might even say you use 3.14 to represent pi. By the time you punch pi in your calculator, it gives you a long series of numbers, which is not actually 3.142. So 3.18, blah 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 blah, like a lot of numbers, that way. So that makes pi, all right, an irrational number. So an easy way to tell if a decimal number is a rational number is two things. It is either exact, like it either has an end, like an end, for example, 1.25, 2.84, something like that. Either has an end or it is recurring. Like after the decimal point, then you have recurring numbers. So 1 over 3, for example, that's going to give us 0.333333 like that. So that is a rational number because the decimal is recurring like that. And then 1 over 3 captures 0.333 exactly, as it is. So on and on like that. Now, we've said that sort are used to, express rational numbers, precisely. So what then are the things that we need to kind of learn about sort? Examples of sorts. So we're going to like talk about sort like and finish the whole thing in this particular lesson. Number one, you have 2 root 3. So this is an example of sort, 2 root 3. Um, Number two, we have root 5, root 7, right? And then you may have something like maybe 4 root 27, like blah 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 like that. So that's it about examples of sorts. So we can expand to root 3. Like what does 2 root 3 actually mean? So 2 root 3 is actually like the number that you have here. So multiply it by itself, like square it and multiply by what is inside. So what do I mean? 2 root 3 is basically root 2 times 2 times 3, right? And then this is going to give us root 2 times 2 is 4, right? 4 times 3 is 12, so root 12. Right? So we can express this in this form. So if you want to break this guy down again, so what do we look for? Is there a perfect square in root 12? Yes, there is a perfect. You can express root 12 um, as a perfect square. Not like the whole of it, like a part of it. So which is to say root 12 is same as root 4 times 3. And what this means is root 4 multiplied by root 3. So root 4 is 2, multiplied by root 3 gives us 2 root 3 back. Right, so the same way, what we have here, root 5. So what's the number like here is 1, then root 5, like number 1, then root 5. So like we can't really do anything to this, we can't express this in this form, like it's already okay the way it is. Now root 7, the same thing, then 4 root 27, so that's going to be 4 multiplied by 4. Right, so this is actually 4 times 4, then times 27. So which is root 16 multiplied by root 27. Root 16 is 4, then root 27. So, but then even root 27 we can still express because there's still a perfect square inside of it, which is 9. So we can still say 4 root 9, then times 3. 9 times 3 27. So this is like 4 multiplied by root 9 multiplied by root 3. So 4 times 3, then root 3. And this is going to give us 12 root 3. So this way, you've learned about multiplication of sorts already. So before even going into like deeper things. So it's as simple as that. Right. So if you want to like bring this guy back to 427 or like make it like proper, so just do 12 times 12, like root 12 times 12, then times 3. So that's the root 144 multiplied by 3. So whatever it gives you. Alright, maybe 512 or whatever. Like I don't even know exactly. So yeah, that's like the simple thing about so I've simplified some things there. So I still have a couple of questions there. How do we simplify these examples? Then we go to addition, we go to addition and subtraction, then we do rationalization, and then we're good. So yeah, we have two different kind of exercise examples anyways. So simplify the following. This first one, how do we simplify all of this? So solution. So for example A, 2 root 10. So if you say a question like this, how do you simplify 2 root 10? So 2 root 10 is an example of what I taught you just now, is equal to then root 2 multiplied by 2, then multiplied by this 10. Like just square whatever is here, Then 2 times 2 is 4. 4 times 10 is 40. So this is root 40. You simplify it. That's okay. Then for this is A. And then for B, root 56 divided by root 2. Since they both carry the root, so they are actually root, a bigger root, 56 divided by 2. And this is equal to root 28. So can we express 28, as a multiplication of a perfect square? Yes. So root 28 can still be expanded to give us root 4 times 7. Alright, so essentially, this is like root 4 multiplied by root 7. I'm expanding it this way because of those of us that like things broken down for us before we can, like, we like mathematics being broken down to tiny bits so we can understand them. But I don't think I'll be repeating these simple things like along the line anymore, because I believe that you've understood it by then. So root 4 is equal to 2, then multiply by root 7. So you are through, done. Then root 7, no, then root 72 times root 65. So root 72 multiplied by root 75. So if we expand this, can we express 72 as a, like, in the form of a perfect square? Yes. So this is basically going to be root 36 times 2, like the root covers everything, then multiply by root, we can also express 75 as a form of a perfect square. That's 25 multiplied by 3. 25 times 3 gives us 75. Now 36, root 36 is 6, so this is going to give us 6 root 2, then multiply by 5 root 3. So essentially, in Surd, you can multiply this by this. So you are going to be having 6 multiplied by 5, then multiplied by root 2, multiplied by root 3. Still writing it like a baby, it's fine. 6 times 5 is 30, multiplied by root 2 times 3, since both of them are in root. So this is 30 root 6. Alright, 30 root 6, and we're good. We're good. So that's that about the first part. Now, the second part says express each of the fraction with a rational denominator. So these are irrational number, like you have irrational denominators. Root 5 is irrational, root 3, then root 3 also. So what this is trying to tell us that is that we should eliminate the um, irrational denominators and like leave this with a rational denominator. So for you to like attack a question like this, so what you just have to do is that you multiply numerator and the denominator by the denominator. So what do I mean? So for A, the first question, which is for A, if the instruction is that you should express each of the fraction with a rational denominator, so this will be equal to 2 over root 5, then multiply by root 5, divided over root 5 as well. So that's it. Now 2 multiplied by root 5, that will give us 2 root 5. Now you have root 5 times root 5, which is root 5 squared, root 5 squared. The square will cancel the root, so we are left with 2 root 5 divided by 5. That's it. Or if this is like problematic for you to understand, root 5 multiplied by root 5 is equal to root 25. And root 25 is 5. So that's all. But instead of going this long route, you can just do root 5 square. So square cancels root. Because anything root from before you can be attending this class, you must have done indices. So anything that has root is actually like raised per half. So essentially root 5 here is 5 raised per half. Alright, so you're now doing 5 raised per half multiplied by 5 raised per half. So 5 raised per half plus half is 5 raised per 1, and that will give us 5. So that normal indices. Alright. Now the second one, it says root 7 divided by root 3. So we multiply the numerator and the denominator by the denominator to clear that out. So for B, root 7 over root 3, and multiply by root 3 divided by root 3. So root 7 times this is going to give us root 21, and divided by 3. So that's all. So 21 divided by 3. So I don't think we can express 21 as a perfect square. So that's about that. Now for C, root 8 over 2 root 3, right? So you multiply 2 root 3 divided by 2 root 3. So what this becomes, the numerator becomes 2 is equal to 2 roots 8 times 3 is 24, 2 root 24, divided by this one, 2 multiplied by this 2 is 4, then root 3 multiplied by root 3, that's 3. You understand? Like root 3 times root 3 is root 3 squared, what we just did here. That's multiplied by 3. So this is going to give us in 24. Is there something that we can do? 12 times 2, 8 times 3. Okay, I think you can do it 4 times 6. Yeah, you can do it 4 times 6. So we have 2 root 4 times 6, 2 root 4 times 6, now divided by 12. Now root 4 on its own is 2, right? So that 2 here, so we are going to be having 2 multiplied by 2, then multiplied by root 6 divided by 12. So this is 4 root 6 over 12. 4 here 1, 4 here 3. So we have root 6 divided by 3 as the final answer. So we cannot cut that below this point. So this is it. If you have questions in this form. So next thing I want to go to is addition and subtraction of sorts, then rationalization of sorts, then your assignment, then bye-bye. These are the last set of exercises that we are going to be doing. So here, simplify 5 root 18 minus 3 root 72 plus 4 root 50. So what do we do? I intentionally just brought this kind of example so that I will learn addition and subtraction at the same time. So when you have a question like this, what you have to kind of do is you have to express the roots in terms of the same number. Like you should try your best to see if you can work out the whole thing in terms of the same roots, everything having like the same roots. You know, here you have 18, 72, and 50 in the roots. So you able like bring them to become the same number. But if you can't, then you leave it like the way it is. Like just try. So whenever I have a question like this, just try. Now 5 root 18, I, which is under example C. 5 root 18 can be expressed as 5 root 9 times 2, right? Minus 3 root 36 times 2. 36 times 2 give us 72. Then plus 4 root 25 times 2. All right, so root 9 is 3. 3 times 5 is 15. So we have 15 root 2 minus root 36 is 6. 6 times 3 is 18. 18 root 2. Then plus root 25 is 5. 5 times the 4 that's already here is 20. So we are left 20 root 2. So this way now, everything is in terms of root 2. So we could just do 15 minus 18. That's minus 3. Minus 3 plus 20. That's 17. So we have 17 root 2. And that's our final answer. Not difficult at all, right? But if this one had been like a root 3, even like at best, like what we did like at best, that would have meant that I would have been able to like subtract only this from this. So if this were a root 3, so that means it would have add minus 3 root 2 plus 20 root 3. So if this was a root 3, like there's nothing you can do, just leave it that way, right? So that case would have been minus 3 root 2 if you add this, then plus 20 root 3. But since we can also bring this guy down to 2, so like we have this final answer. That's it. Now for the second part, which is the final part that I want to do, it says that you should simplify the following by rationalizing the denominator. So rationalize, like you want to like give it a number, like you want to give it a rational number. We don't want to leave it like in this form. So what we do is similar to what we did in the previous example, like before this. But since this is like a combination of two different irrational numbers, like plus 15 plus root 10, so we are going to multiply the numerator and the denominator by the denominator, but the sign will change. So here, since we have a plus here, when we are multiplying, this plus needs to become a minus. For everything, we also have a plus. So if this one had been a minus, for example, and when we are multiplying, then we have to like change this minus here to plus if it had been a minus and on and on. But like for this one, we just happen to have plus all through. Or maybe I should just change this to minus. Let me just change this one to minus. There's no problem. So let's deal with it. So for this I, root 15, that will going to root 5 divided by root 15 minus root 10, then multiplied by root 15 plus this minus becomes plus root 10 over root 15 plus root 10. So we start root 5 multiplied by root 15. So that's going to give us root 75 here. Then plus root 5 times this as root 50. Then divided by root 15 times root 15. That will give us 15. Root 15 times plus 10 plus root 75 plus root 150 minus root 10 times root 15 minus root 150, then minus root 10 multiplied by plus root 10. So that's it. Minus times plus will give us minus. Root 10 times root 10 will give us 10. So plus root 150 minus 150 will cancel out. Like it is always like this. It's always like this. So if it is not canceling out, then that means you've done a mistake. You go back to your work. Because I try to rationalize. That's why we are changing the sign from minus to plus, if it was plus to minus, so that these two can take each other out. And we are just left with all numbers. So yeah, root 75 is going to give us root 25 times 3, then plus this one is going to give us root 25 times 2, then divided by 15 minus 10 give us 5. So root 25 times 3 is going to give us 5 root 3, right? Plus this is root 25 is 5 root 2, everything divided by 5. So yeah, something interesting can happen. We collect 5 out. 5 into bracket root 3 plus root 2, then divided by 5. So this can take this guy out. Then we are left with root 3 plus root 2. This should be the final answer for this particular question. So you can see that it's not a difficult thing. So let's start the next one, which is 3 over 2 root 3. So 3 divided by 2 plus root 3, then multiplied by 2 minus root 3 over 2 minus root 3. Okay, so this is like 3 into brackets 2 minus root 3. So this way can put this in perspective better. And 2 multiplied by 2 is 4 plus 3, 2 multiplied by this minus 2 root 3 plus 2 root 3. And root 3 plus times minus is minus. Root 3 times root 3 is 3. So maybe I'll just be eliminating this middle one. Like maybe I'll not even bother writing them out because they were going to eliminate each other anyways. So yeah, 3 times, so this can give us 3 into bracket 2 minus root 3 divided by 4 minus 3. 4 minus 3, which is 1. Okay, so go let's decide to say, okay, 6 minus 3 root 3 divided by 1, which is the same thing as 6 minus 3 root 3. So the final answer is 6 minus 3 root 3, or you could leave it as 3 into bracket 2 minus root 3. So anyhow. So you can see how simple it is. Then the last one that is looking a little bit funny. So how do we approach that? So I 2 root 3 minus root 5 divided by root 3 plus 2 root 5 and multiplied by root 3 minus 2 root 5 divided by root 3 minus 2 root 5. So what can we do? So from this place, we'll begin to like multiply one after the other. So 2 root 3 multiplied by root 3, right? So we have 2 root 3 like this, into brackets root 3 minus 2 root 5. This 2 root 3 multiplying everything here. Then minus root 5 into brackets root 3 minus 2 root 5. So everything divided by. So I'm not bothered to do this times this or this times because I know they're going to cancel out anyway. So the one I'm bothered with is root 3 times root 3. That will give me 3, right? Then plus times minus is minus. Like I want to like multiply this by this. No point doing this and this and this, this and this. They will remove. They are going to cancel out each other. So 2 root 5 multiplied by 2 root 5. That's 2 root 5 squared. So like 2 times 2, 4. Root 5 times root 5, 5. Yeah. So yeah, 2 root 3 times root 3. So root 3 times root 3 will give me 3. So then that 3 multiplied by 2 is 6. I have 6 minus 2 times 2, 4. Root 3 times root 5, root 15. Then minus root 5 times root 3 is still root 15. Minus times minus is plus. 2 root 5 times root 5 is 5. Like the 2 here is out, like 1 multiplied by 1 is here, that is not visible. 2 and 1 times that 2 is 2. Root 5 times root 5 is 5. So everything divided by 3 minus 20. Okay, so some things are common. 6 then plus 10. So 6 plus 10 times 5 is 10. Then this is minus 4 root 15 minus 1 root 15. Like what's this? Like an invisible one. That's going to give us minus 5 root 15 and divided by minus 17. So we have 16 minus 5 root 15 divided by minus 17. So this minus is more or less like affecting everything. Like we could just write this as minus into brackets 16 minus 5 root 15 divided by 17. Like it's clear, right? So instead of I've taken the minus away from here, I've put the minus like to like affect the whole thing. So from there, minus times 16 is minus 16. Minus times minus is plus 5 root 15 and divided by 17. So I could rearrange the numerator to give us 5 root 15 minus 16 divided by 17. So you can see this does not contain any rational number anymore. And yeah, this is the final answer. I don't know that it's anyway. 5 root 15 minus 16, yeah, over 17. So that's it. What we now want to do is the assignments that you're supposed to do and submit, or submit to your teacher, or submit to, of course, submit to your teacher. So yeah, you have this simple assignment to deal with. Simplify the following as far as possible. I 4 root 3 minus root 12. I 3 root 27 minus root 48 minus 2 root 75, then plus root 108. Then 3 root 2, then everything cube, right? Everything cube. Then simplify the following by rationalizing the denominators. Number 1, 5 root 3 minus 3 root 5 divided by 2 root 5 plus root 3. Then number 2, 3 root 8 times 5 root 3 times root 7, everything divided by root 42 times 2 root 3 times root 15. In this context, now let me just guide, let me help you out. Multiply all of this, and the way you rationalize was like the first one that we did. So what you are going to get, like just one irrational number. So you multiply the numerator and denominator by that irrational number. Like there is no plus or minus in between. So you gotta try to say, so like this one, like when you are multiplying, you change plus to minus. Here, I just want to, when you multiply all of this, you're going to get one irrational number. And multiply both sides by that irrational number, and then that's about that. So see you in the next lesson. Have fun. Bye. Take care.